Nick, the floor is yours.
Thank you very much.
There's also a Keynote version in the same directory.
Oh, the Keynote version is working very well. Do you want to see the problem there? Okay, full screen mode. My God, technology, isn't it great? Okay, thank you very much. My name is Nick Hilliard. I'm Chief Technical Officer of INEX, which is an abbreviation of Internet Neutral Exchange Association Company Limited by Guarantee. We had a name change. The CLG thing got added on. It was an act of law. We couldn't do anything about it. It's kind of minging branding, though. I'm going to talk about automation and what we've done. A bunch of people in the room will know about IXP Manager. It is a system which we designed and built for running IXPs. It had two reasons, actually, for being built in the first place. The original reason was just to manage customer information. But actually, the reason that we turned it into a thing was in order to support root server configuration builds. Which is to say that we saw the value of automation and automating early and often. So it contained an awful lot of useful information about IXP participants, like switch information and interface information, but it was always maintained as something which stood on its own, and then there was the switches, and we would always manage the switches by hand. There were a bunch of reasons for that, actually. It was the sort of thing that was going to take quite a lot of time and effort. Deployment was difficult. We didn't want situations where somebody would suddenly find a security hole in IXP Manager, and then they could use that and wipe out the IXP configuration online, and then suddenly there'd be a major outage, and it would cause a lot of trouble. So we didn't want to really go down that sort of end of things. But mostly the problem was that there was very poor tool support. So there were tools like CF Engine, Ansible, Chef, Puppet, that sort of thing a couple of years ago. In general, they couldn't actually interface with network devices. A network device is a relatively simple thing. It's not a server. You can't run your own agent on it. It won't do things like, it's very difficult to interface with these mechanisms. There were always some network devices that could run them in some way or other, but it was kind of non-portable. The tools of the era, everybody has used Rancid. I hope most people in the room have upgraded to Oxidized at this stage. We'll overlook the fact that it's Ruby, but even still, it's better. I think everybody's gone through the oh my God stage with Bash and Perl scripts. This sort of stuff just doesn't scale. It scales hilariously badly. But there were no overall framework mechanisms that we could kind of use to approach the problem. We wanted to approach it from a framework point of view, which is to say get something which we knew would have all of the plumbing built in and done for us, because we just didn't want to have to deal with that sort of stuff ourselves. Okay, so it's 2017. We're in a much better state. We've got lots of automation systems. They can now interface with network devices fairly well. And all of these NOSs have APIs or API models of various sorts. Some of them have multiple APIs. It's great if you want different options for configuring your system. Our rationale has changed in terms of how we looked at this. We actually sat down and we thought, we looked at all of the outage problems that we were having, and it turned out that a lot of these were associated with pilot error. One of the worst examples that we had in recent years was on a device which had a 4-way lag to an organization, and one of the lag members had some legacy configuration on it which blocked MAC addresses, and that just caused an awful lot of fun. That was really hideous. So that was a huge driver in terms of getting us to move away from that model. But also, there's an element of cost reduction here. INEX is an organization which services about 100 connected members. We run that on 2 FTEs. That's quite a small number. That's split up over multiple people, but it's still 2 FTEs. In terms of goals, our initial operational goal, which was defined at the end of last year, was to design and build a system which could use the IXP manager data to configure all of our edge ports. So there was a whole pile of information there: speed, framing, lag ports, layer 2 filters, that sort of thing. We decided we were going to go one step ahead and configure our IXP core as well. And the reason for that actually was we were doing a forklift upgrade, and we were moving from there, from a layer 2 core to a layer 3 VXLAN core. And we looked at the number of individual data points. We were using 8-way lags, 8 by 10 gig lags around the network. And on each of those, you'd have an interface configuration on one side, you'd have an interface configuration item on the other side. You'd have BGP on one side, BGP on the other, and in each BGP session, you have unique data. So there were about, I think about 200 individual configuration items for the network, all of which were massively repetitive and almost impossible to visually inspect for correctness. That was 200 basic configuration items. Each of those configuration items had multiple steps associated with it. It might have been a different ASN number, a different IP address, different interface numbers. So there was an awful lot of data, all of which looked the same. And we knew that if we configured this up manually, we were going to bugger stuff up. And we didn't want to do that. We didn't actually have the back end for this in IXP Manager, so we actually wrote a quick meta configuration system using Perl scripts. It was a temporary thing, but actually there was very good reasons for it, because it allowed us to model what we were doing in what we thought was a sensible way, and we learned from what we did, as we'll see later, to and implemented it in IXP Manager. Phase 2. This was the long-term phase, which is to say that we wanted to find out how to automate stuff properly for an IXP. We wanted to build all of this into IXP Manager. There's a couple of different components there. There's a user interface, there's a database backend, and then there's information presented for export on REST APIs. It was important to us that the data model, the data storage and presentation models that we used were going to be portable. And the portability requirements were not just for INEX, but for other IXPs, not just for Arista, which was the network devices that we were upgrading to, but also different types of switch and router model. And finally, to release this as open source so that other IXPs can deploy this. Okay, so what's out there? Well, there's a couple of major approaches towards interfacing with network devices. I'm not really going to go through this, except to say that these approaches are terribly, terribly different from each other. OpenFlow is a little bit like, in some ways, programming your network using assembly language. You can do some amazing things with it. It's really cool, but it's just too low level. We didn't want to do that. We thought it was actually going to create a lot of support issues for us as well. You know, what happens when a flow rule messes up, and you know, we have to sort of escalate effectively every problem to level 3 engineering. That wasn't going to work for us. Yang looks terribly interesting, but to be completely fair to it, it's not there yet. It's only really well supported by one or two network operating systems and not the ones that we were using. Which kind of left vendor APIs, which are a mixed bag. They have good points and bad points. But one of the very good points about them is that the relative level of complexity from the user interface point of view is actually quite low, which low can actually reduce costs. So that's what we figured we would do. We would use NAPALM, which is an abstraction layer for vendor APIs, which will interface with your automation tools. And which is supported and used by very big organizations, such as Spotify, such as Cloudflare. There's all sorts of organizations using NAPALM at this stage, and it's good. It's also getting a lot of vendor interest as well, which is, I think, is very important. Right, vendor APIs. Okay, these are problematic because it turns out that most of them are just a sort of a fancy way of saying we've taken the CLI and we've moved it to JSON or XML on a web interface. So it's an evolution. It's not a revolutionary approach to configuring boxes, but it is a little bit better. You have mandatory security. Everything goes over HTTPS or SSH or whatever it is. Everything is a little bit more structured. It's all XML or JSON. It's a bit better. But you also have a very good feature, which is that when you issue a command, you get a reply. And you don't have to mess around with trying to do stuff like parsing command prompts. The amount of nonsense, if anybody actually looks at the rancid or oxidized mailing lists, the amount of, bug lists, the amount of nonsense associated with how to parse a CLI prompt on a network device is completely ridiculous, actually. Some CLIs cannot be automated terribly well, and this is an issue. And I'm going to talk a little bit later on about non-idempotent command support. And a bunch of CLIs and consequently APIs do not support really, really fundamental building block functions such as configuration merge, configuration commit, and configuration rollback. And of course, obviously, the APIs are very, very specific to NOSes. They can be version specific as well. We have some devices on our network which, due to the fact that they're only just end of sale, they will never get any more major software releases, and because of that, they will never see any vendor APIs. It's a bit of a drag, but there we go. Now, this table here, I'm not going to go through it. This is pulled straight from the NAPALM website. What I do want to say is that there are some things about this table that I find to be deeply disturbing, and vendors, please take note. Every single option, every single entry in that table should be yes. And if your network operating system does not have unqualified yes in there, you have a problem which you need to fix. These are some of the caveats up in the top right-hand corner. It's a little bit difficult to see that, but you have caveat number 2, handcrafted by the API as the device doesn't support the feature. 3, not supported but emulated, check caveats. And then you have a couple where it's just uniformly no everywhere. These are things which are really important for automation. And without these functions, without this functionality, automation has really serious problems. So vendors, please make sure your products fix this. Okay, in terms of what we have 5 operating systems that we either have or are looking at. Brocade FastIron, NetIron, Extreme XOS, Arista EOS, and Cumulus. And they're all in various life cycle stages at the moment. In terms of assessment for automation, we are going to fully automate Arista and Cumulus. Arista is in production at the moment. Cumulus is in pre-deployment. We are going to partially support Extreme XOS. partly because there is no NAPALM interface published yet. There is one in development, but it hasn't been published yet, and it will have problems due to the way that ExtremeXOS works. You can also see that some of these switches actually have quite good support for features like OpenFlow. OpenFlow would have supported more of our hardware, but we decided not to do it for cost and complication reasons. Okay, so which automation framework do you use? This is totally not a religious issue. We had some very sound engineering decisions for choosing SaltStack. Our rationale for choosing SaltStack originally was, well, for choosing it for this project was that we were using it everywhere. So there was no point in using Ansible for just this and SaltStack for everything else. There is actually no reason that you couldn't use Ansible. Ansible is possibly better supported for NAPALM. So the advice here is use what you're comfortable with. We use SaltStack because a friend of mine used SaltStack and she liked it, and she said it's like so great, you've just got to try it one day. And it was like, okay, that's cool, we'll try it. And we liked it, it was cool. There you go, sound engineering decision. Okay, so here's the data flow. Do we have a pointer? Yeah, maybe not. Okay, not to worry. All right, so roughly speaking, oh, yes, there's a, yes. Okay, here we are.
Oh, I can breathe. Okay.
All right, so yeah, our IXP Manager database, that's an SQL backend. We have a data export controller, which is code. It's written in PHP. Please don't puke. PHP has its good points, and if anybody pukes, bear in mind I'm holding a laser pointer and I will zap your eyes out. That data is exported via a REST API, and it's exported using YAML. YAML, yet another markup language, is one of these things that's been around for years. Ansible and Salt use it, and because they use it, we figured, well, we could have exported using JSON or spit XML, but we figured it's actually just easier to use YAML because it's supported natively. Salt will then do some magic machinations with NAPALM. And then that'll use the Salt proxy to talk to the network device API, which will end up with a running configuration. At this stage, I need to tell everybody what a wonderful crowd of people Cloudflare are, and in particular, Mircea Ulinik, who has done the integration of NAPALM into the Salt framework. What he's done is really, really excellent, and he's effectively, as far as I can tell, given NAPALM and Salt as good support as NAPALM in the original Ansible. He's given some presentations, one at RIPE, one at NLNOG. If you haven't looked at them already, please do so, because they're exceptionally good presentations. He also has a blog on the internet, which goes into an awful lot more detail about the nuts and bolts about how this sort of thing works. Okay, that's a traditional NOS. A traditional switch or router network operating system has one defining feature, and that is that it has a single configuration interface. Okay, that configuration interface could be an API, it could be a single command file. That's not the case, not particularly the case with Cumulus Linux. Because Cumulus Linux is Debian plus switchd plus a whole bunch of Cumulus stuff. Which is to say that there isn't a single configuration file. If you want to configure LLDP, you edit llDP.conf. If you want to configure an interface, you go into etc. network/interfaces. If you want to configure BGP, you edit etc/frr/frr.conf, and so on and so forth. Which means that it doesn't particularly work with NAPALM, and probably never will work satisfactorily, unless the fundamental design mechanism of NAPALM changes. However, because it's Linux, it will talk directly to Salt or to Ansible. So we can actually skip out the entire NAPALM mechanism in there and just use regular Salt. Okay, IXP Manager, API version 4, exports YAML. And there's 4 rough types of data. There's VLANs, there's layer 2 interface information, there's layer 3 interface information if you have a layer 3 core, and on top of that you've got the information needed for the rooted cores, such as BGP. If you're using static VXLAN, you need a flood list of all of the other loopback addresses. All that sort of stuff is in there. This is what it looks like. So you can kind of see roughly, this all looks like really simple. This is a physical edge interface. It's not, it's part of a lag, but it's not the actual lag interface. So some tokens are actually unnecessary, like FastLACP. It's type edge, it's got a description, .1q, all that sort of stuff. And because we use MAC filtering, we have MAC addresses defined everywhere. This interface, on the other hand, is a core interface. What we're doing with our deployment is, or our implementation, is to define a mechanism which will allow an IXP to run either a layer 2 core or a layer 3 core, or a mixed core. There are certain specific instances where running a mixed core actually makes quite a lot of sense. There's no stuff about filtering in there. The core type is core up there, and you've got a list of VLANs, and you've got your .1q, and you've got shutdown, all that sort of stuff. You've got spanning tree cost as well, so that enables you to do smart stuff with your configuration. Okay, so data templating. You take your YAML data, you plug it into a bunch of Jinja templates, and then you end up with your configuration, so that's cool. This is what a Jinja template looks like. It's kind of sort of bit based on Python. If you know Python, you'll be very comfortable with Jinja. Essentially, we're exporting our data. We're going to change these tokens interfaces cost to other stuff because we've kind of overloaded them at this stage. But you end up with basic stuff like this. So if we're going to iterate over all of that, and we can see here that this is an interface of cost. So you've got a name, and you've got a description, and you've got shutdown. And then in the template, you've got the iface.name, you've got the description, and then you've got other options there that you can just plug in. It's all pretty basic. Mirchow says you don't need to be a programmer. He's kind of right. You can kind of dabble, you know, but like not inhale. It's pretty easy stuff. And of course, a lot of people write these things by cutting and pasting from what other people have done. You don't have to be a very good programmer to make this work. You do end up with like weird stuff like this. This is how to configure speed on an Arista box. Okay, so Arista, this is a slap. Please don't do this sort of stuff. That should be speed followed by a digit. But you can see that you can do more complicated stuff than based on your inputs there. Okay, but you also run into problems, and this is why we wanted to leave phase 2 until we had multiple types of network device on the network, and that is that different switches use different data models. Okay, and a really good example of this is link aggregation. So on a Brocade device, you have interface Ethernet 1 to 2, and then link configure key, whatever the key name is, and then it'll just magically create a lag. But there's no pseudo interface created. It's just physical interfaces. Extreme just uses the physical interfaces, but you have to enable sharing. You just say enable sharing and then a number, ports 1, 2, 3, 4, 5. Other devices will use port channel or bundle Ethernet or bond or whatever it is as the name of the virtual interface. But even then, you run into some really weird deployment problems. So for example, on a port channel, you go into the interface definitions, you say channel group 1. But on Cumulus Linux, you go into the lag interface and you say iface bond 0, and then you say bond slave switchport 1, switchport 2, switchport 3. So there are differences in semantics there that need to be taken into account. And this was a very important lesson, I think, that different device models are different, and any device, any interface or data model abstraction that you're doing, it needs to be flexible. It needs to be designed in a way that you can change it, because sure enough, in a couple of years, you'll get a device which, you know, is infinitely configurable, but it'll use a different model, and you'll run yourself into trouble. Problems, oh my God. Upgrades. Upgrades of servers causes infinite trouble. One of the big problems that we ran into was actually when pip install starts fighting with the package management, because, you know, on a device, on a controller device, you know, you have a bunch of things which will run, or which will need Python installed, and apt will install a whole bunch of Python stuff, and then you need to pip install all of the NAPALM stuff, and then you do an upgrade, and it wipes out some stuff, and it's a real mess, actually. We actually found that for upgrades, it was actually sometimes easier to wipe out everything to do with Python and to do a complete reinstall of everything to do with Python in a particular order. We've actually ended up documenting that in our internal procedure guide, because it just caused so much trouble. Okay, so this is DevOps territory, and in DevOps territory, it's like walking around a building site. So you would expect that Jinja 2.7 to 2.9 is not going to break things because it's not a major upgrade, right? This was not a valid assumption at all. So this is Jinja 2.7, works very well. If you have a data structure in there, so your interfaces.cust.shutdown, if that is not defined, well, iface.shutdown will be evaluated as false. So if iface.shutdown won't be evaluated, so that'll be okay. But DevOps guys, you know, they kind of got a dose of bad programming, and they decided, no, we're going to do sort of semi-strict typing here. So what they've decided is that these mechanisms will no longer return null or false. They'll return a stack dump. And it just breaks everything. I mean, like, why? Why did you do this? This is just stupid. So we've actually ended up having to ship all of our Jinja templates with if iface.shutdown is defined and iface.shutdown, which is a real pain. It just makes everything look really, really complicated when actually it isn't. And we've had to encase entire for loops with if the thing that we're iterating over actually exists, because it might not. It might just be a blank list of no interfaces. You can fix that at the data export level, but you know that's just another way of breaking your you're exporting null information, which is kind of a bit, I don't know. Salt, dear God. What the hell does this mean? napalm.getGrains key error. This was caused by a package upgrade on the main operating system. And Python just started getting into a fight with itself. But that actually wasn't quite as bad as what happened when we upgraded Salt from 2016.11 to 2017.07. We ended up with this completely impenetrable error, which you can only barely see there at the bottom. Type error, bool, object is not iterable. Okay, it turns out that that means that the 2017 version of Salt is not particularly compatible with the 2016 version of Salt, so you've just got to upgrade everything and it all works fine. But for goodness sake, Salt guys, would you just please put in warning, you are running a 2017 master with a 2016 slave, don't do this, instead of pumping out this sort of nonsense. I mean, come on, this is crazy. Okay, idempotent configuration merge. This is one of the coolest things you've ever come across. when you were defining interface configuration stuff in your templates, you can blast away old configuration. Okay, so we start all of our configuration with, for example, no router BGP, and then we define a completely clean router BGP section. Okay, same with interfaces. We have default interface. That which wipes out absolutely everything on the interface. And that is wonderful because it means that we know that when we issue a SALT or a NAPALM defined template to a switch, that it is effectively, for that particular configuration stanza, it's starting off with a clean slate. This is incredibly useful, and it's so wonderful. And then when you run into switches which don't support it, I mean, it's catastrophic. It's really appalling. I had a chat with Eric over here about this on Extreme. Extreme XOS is non-idempotent. MikroTik is non-idempotent. When you issue the same command multiple times in the row, you can't be guaranteed that this is actually going to work. But this works. This is labeled config merge on the NAPALM website, but it is a hugely powerful tool. Okay, so deployment workflow. When you were deploying this, use different environments. We have a lab environment and a production environment. It means we can do stuff safely on what is effectively a production server, but only affecting lab equipment. You can do stuff like virtualized images. You have the most amazing capacity to test out systems. Here's how it works. So we make a change in IXP manager. We do a saltutil refresh pillar. I'm not going to go into what these terms actually do. Refresh just means refresh the data from the database. And that means that you always have a consistent view of what information the salt master actually has. And then this complicated looking command here just deploys a particular template. You can see at the end, test equals true. We always test before configuration. The second stage is we run the command except its commit equals false. So that will actually deploy the configuration to the box, but it won't commit it. And the third step is just to change that to commit equals true. Oh, damn it, god damn it. To commit equals true, and that will actually commit it. You don't want to, you need to be a little bit careful about this because when you set commit equals false in NAPALM, it will actually keep a configuration lock open on the device configuration, and that can mess things up. So you do need to be careful with this mechanism. We sometimes, if it's a simple configuration change, you know, for a Mac ACL or something like that on an edge interface, we'll just skip the commit rollback side because it's so obvious what it's going to do. Here's how it works on the Cumulus side. It's just regular salt. We've made a configuration change affecting BGP to remove a bunch of neighbors here. So it's figured that the FRR configuration has changed. And that means that the configuration is set to be reloaded over there. And that will do configuration apply on the lab environment and test equals false. So that'll actually go off and deploy it. Okay, so phase one results. We have all edge ports now deployed from our production database. We have our IXP core deployed from a pilot model data source. The forklift upgrade that we did went incredibly smoothly. I mean, there was one problem with an MTU, which was a template change, and that was it. It was amazing. It saved us so much time in messing around. It was worth it just for that. Our operations workflow is vastly better. It's simpler, safer, and a lot more reliable. And now we have a single source of authoritative data about our network config, which is very useful. In terms of where we are, where we want to be by the end of the year, the data abstraction model is complete. It needs a little bit of refactoring. Same with the coding. That's pretty much complete. The templating is finished for Arista, almost finished for Cumulus. We're hoping to get this released in Q4 of 2017. And we're also going to build out a bunch of documentation and operational workflow. I'm going to get killed by this when I get back home because Barry, our office beater-upper, is going to beat me up about writing documentation, which I absolutely hate. Doesn't everybody? Yeah, we all hate documentation. Okay, so there we go. This is how it was. Configure, manually log into switches, and then years later you find configuration mistakes, and you think, how the hell did the network work like that? Jesus. Now it's configure up, refresh the pillar data, and deploy, and it's wonderful. Okay, any questions?
Hi, Stephen from M6. There's one question. It's really interesting. If you can go back one slide, I think it's one slide. Yeah, so the refresh salt pillar data, is that something that you trigger automatically, or is there actually an engineer that says refresh the data and push it?
This is a salt feature. You can do it either way. And the reason is that in salt, you have a master controller, and the master talks to minions. Now, there is data on the master which is specific to each minion. That's called pillar data. And Salt is very careful about keeping a consistent set of pillar data. So that means that if you change your backend data source, so these are all API calls, it will not, we've configured it so that it doesn't refresh the pillar data automatically. Which means that we just manually run a command to do that. And the reason for that is to ensure that we have an atomically the same set of configuration data at any particular point in time. And it's effectively a live snapshot of all of the data in the database. But you can do it any way you want. I mean, if you want to issue a trigger from your database mechanism, which will update at any time you update, say, an edge interface or a core interface or whatever, you can do that too. But then it would basically go over all the data, see what changed, and just regenerate all the configs? What it does is it updates the state configuration in the salt master database. Okay, and then you can issue a command instead of. If we go back here, you can see that we're only targeting a single switch over here, switch 1, ParkWest 1-1. Yep. You can say salt star, which is to say go to all of the switches, run it with test equals true, and it will show you a context diff of all of the configuration changes that would be made on any of the switches. And this actually deals with one of our other neuroses about the automation, which we mentioned earlier, which is to say that we wanted a mechanism of automation that we could control, that there would be a review process in place before any configuration would be rolled out, while at the same time the individual templating mechanisms here will allow us in the future to do things like give the ability for, say, an IXP participant to log in, change their MAC address, and as soon as they've changed it, that'll trigger a state update, and then that'll push the configuration out onto the switch, which is possibly where you're coming from.
That's exactly where I'm, yeah.
So there you go.
Good guess, yeah. Okay, thanks.
Final question for you.
Christian, visitor from the NLNOG. I was watching your pains with Python dependency management, and I wanted to pitch in and say, as a writer of various dodgy Python scripts that barely work, I found that running them on my own laptop is easy. Deploying them where they actually need to run is very difficult with the correct dependencies and so on. So the tool that actually helped me in probably a completely messy way to solve this issue has been Docker. So basically, take the thing, package it into a container that has all the minimum required dependencies in it and nothing else, and then run that wherever you need to run it. And it's made things so much easier. It's a bit of overhead to learn Docker and have a machine that can run Docker, which is Linux, pretty much. But then the workflow itself is made so much easier because you just have scripted, you can use Ansible or Salt to just create a container and then push it into something like GitLab and then pull it on the machine you need to run, or in, you know, and just keep that in mind.
Yep.
It's another shiny technology, but to me it was an eye-opener.
Yeah, okay, that's a interesting suggestion. Thank you. Cool.
Another way of dealing with dependencies, instead of using this newfangled Jinja 2.6 and 2.7, the M4 interface has been stable for more than 17 years now. I'm just saying, I'm just putting it out there. There are other templating languages. All right. Give it up for Nick Hilliard. Thank you.